Now, different people are using different methods. A couple people originally said, well, I can solve this by finding the slope. Then I've got m, then I just plug that into y equals mx plus b for one of these points, and I get b, right? That's a perfectly valid way to get a linear function through these points, but we want to do it using system of equations, because that's what we really want to talk about here, okay? And, you know, what you did there is fine, but how are you going to use that same idea, slope and so forth, for a system of three equations? It won't work. And it won't work here, and it won't work here, okay? So we want to see the general way of solving simultaneous equations so we have something that'll work in any case, okay? So if I just ask you to find the equation through these 2 points, finding the slope and then using that to find the intercept is just fine, okay? If I ask you to do it using the simultaneous equations, you're going to have to write these simultaneous equations out and then use a method for solving them. Now, the most straightforward method for solving these equations, which is very much like what we did to eliminate a variable from these 3 equations during the first week of class, is let's eliminate b. To eliminate b, we write down the first equation, and then -1 times the second equation, which would give us 12 equals -5m minus b. Now, why would I have written down -1 times the second equation? It's because I noticed that I have a b here and a b here. So if that b was negative, then when I add the 2 equations, the b's would go away. And I'd eliminate b, and then I'd have an equation in m. Well, if I want to make that a negative b, if I want to make this equal and opposite to this, I just multiply the whole equation by -1, which gives me a completely equivalent equation, and then I can add. The sum is then 18 equals 3m. And that's an equation that we can solve to find the value of m. Now, that's the same value of m you'd get if you did rise over run with a fundamental triangle. Okay, you'd have a rise of 18 and a run of 3. Actually be a rise of -18, and I'm glad I looked because this is -3, right? 2 and -5 makes -3. So I was about to write down something completely wrong. So, m equals 18 over -3, which is -6. Now, we take that value of -6, we plug it back into either equation. I'm going to plug it into the first one just because it's closer. And what does that give me? That gives me 6 equals 2 times -6 plus b. I just replace m by -6. And I find then that b, and I'm not going to write out all the steps, everybody can solve this. You got -12, so you're going to add 12, you're going to get b equals 18. Okay? So now, if I did it right, it's going to check. What do we do next? We check. We always check. Because if you solve these problems without checking, you'll never know whether you got it right or not. And you'll never know whether you're doing the right thing, and you won't get the feedback you need to understand, and you won't then come to class and say, hey, these things aren't working out for me, what am I doing? Okay? So, you have this, we check. Okay, y equals negative 6x plus 18. Does the point 26 implies that's like an equal sign with an arrow on it. It's not an equal sign. Equal signs only mean this is equal to this, right? Don't misuse equal signs. It gets confusing if you do. So that means that 6, because that's your y value, should equal negative 6 times 2, which is your x value, plus 18. Well, you can do the arithmetic. Negative 12 and 18 is 6, so we'll put a big old check mark on that one. Okay? Then we have the point 5, negative 12, which would imply that negative 12 equals negative 6 times 5 plus 18. Well, that's negative 30. Negative 30 plus 18 is negative 12. That checks. Right? So this is elimination. Another method is substitution. Okay? Six equals 2m plus b, so b equals 6 minus 2m. Okay, this came from our first equation. Our second equation is negative 12 equals 5m plus b. We plug this expression for b in here, and we get negative 12 equals 5m plus the quantity 6 minus 2m. We've replaced b by this expression for b. So we solve for b, and we get, no surprise, b equals 18. So now we have b equals 18. We have our first equation. We get 6. Well, I'll write it out. 6 equals 2m plus b. So we plug in b equals 18, which gives us the equation 6 equals 2m plus 18. We solve, and we get m equals negative 6. And we get our equation, negative 6x plus 18. Same equation we got here. It checks out in the same way. Okay? So there's substitution, there's elimination. In substitution, you solve one of the equations for one of the variables, and then plug that in for that variable in the other equation. And we're going to use that in solving some of these equations, okay? Now, I'm not going to solve the quadratic system.
Oh, I just did.
I might do that in class, okay? But I'm just going to say review it. We solved many, starting the first week of class. So it's something you did early. So you should remember what you're doing if you did enough of the homework. And if not, videos are there, everything else is there you can review. I'll just say briefly, if you subtract one of these equations from any one of these equations from another, you're going to eliminate C, right?
Yeah.
And then subtract two other equations, not the same two, you're going to eliminate C again, right?
Yeah, you just take the first one and multiply, subtract it from the other two.
Yeah,
And then you
or
get
multiply it by -1 and add it. I usually think it's simpler, or it's safer to
say
multiply by -1 and
-1.
add than it is to subtract, because if you subtract, you get a negative of a negative
That's what I
sometimes.
meant.
Yeah, well, I know what you meant, and I know you can do it, because I've seen you do it. That's not the question. Just clarifying that for everybody. I prefer multiplying by a negative and then adding, so that you get opposite signs. Okay, so anyhow, that would reduce this system to two equations in A and B. And then you can use these methods to solve them, right? Okay, but I want to go on and talk about how we solve these systems. Now, we've done this, so we're reviewing, actually, but we're trying to reinforce what we've already reviewed.